Hello everyone and welcome to a new camera angle and yet another recreation programming session with Mr. Zosi. So we've been trying to add a new demo to our graphics library called Olive-C. Right. And the demo we're trying to add is the demo that is based on this 3D model, right? And this is a 3D model of a penguin. So basically the mascot of our channel. Basically, is it already mascot of our channel? But this is the character that our community came up with, specifically Sifon Altera. But then a lot of people contributed to the character. So you can find more about this character at the website Penguin City. Right, so this is a website dedicated to this creature, right? So there's a lot of emotes, there's a lot of memes and stuff like that. I'm gonna put that in the description for anyone who's interested in this weird, obscure internet meme that nobody knows about. Right, so and people have created this 3D model. So I think the author of this model. So let me actually see. So it's somewhere in the assets. So the author is Max Kawula. I hope I pronounced the name correctly. So I'm going to put their profile here in the description as well. So they are the author of the model. So we managed to add the model, right? So far, and chat is actually posting Penger. The cult of Penger. Right. And we managed to put the model in here, but the model is supposed to actually have textures and also an outline. So I learned a little bit about Blender, so I can try to maybe open the model in Blender. Hopefully, we'll see. Hopefully my laptop will manage to do that. But I mean, it's a new laptop, so I'm pretty sure I'll be able to do that. So let's actually delete this entire thing and let me try to export the waveform OBJ super quick. So I'm gonna go to the assets, and within the assets here is the path. So I'm going to just grab the path and I'm going to copy paste it in here. So I can basically go here and I'm exporting the whole thing. Did it export it? It didn't fucking export shit. I think I did something. I mean import. I don't know the difference between export and import. I'm sorry. My brain having a hard time to. And since I exported an empty thing, it actually overwritten the model, and now I actually lost it. Dude, I do not deserve a new laptop. I don't know how to use computers. How is it to be boomer? This is such a boomer thing to do. Like, holy fuck. I literally do not deserve a new laptop. Like, I don't know how to use computers. Luckily, I use Git. The whole model was under the Git. So, yeah, as you can see, I actually deleted it and stuff like that. I can revert the changes. But you didn't fucking expect that. I thought I'm just some sort of a noob who doesn't know how to use computers, but I used Git and now I reverted the damage. That fucking easy. Anyways, so let's actually try to do that one more time. One more time. And maybe this time I'm gonna use the right option. Actually, let's actually see. And boom, look at that. It's the banger. It's the banger. Your mom's a banger. So one of the things, by the way, we need to go to some sort of like a render mode, right? So where, yeah, so this is the material sort of mode, but it's became completely black because it has an outer black hull, right? And it's a trick that people use to create an outline. So the way the outline is created, the normals of the hull is actually inverted. And if you enable hull, like basically normal culling, it will appear. Right, so backface culling, that's what it's called. Right, so you enable backface culling, and there we go. So this is how it looks like now. So this is a proper penguin. This is how it's supposed to look like. Right, this is how it's supposed to look like. Pretty cool, I think it's pretty cool. This is basically going to be goal for today's stream. We will try to modify this renderer so the model finally looks like this. Right, that's the idea essentially. That's the idea essentially for today's stream. So we will need to put textures onto the triangles. Luckily, we already know how to do that. we already know how to do that because we already done that in here. As you can see, here is the texture rendering. I don't remember how exactly it is done, but I can take a look at the source code. Right, and once we have textures, we'll also need to enable backface culling as well. So for that, we'll need normals, right? We'll need normals, and the way we're going to do that, we're going to actually, I think the way it is done, I don't really know much about backface culling, but I think you just take a dot product of the vector of the camera, right? So the camera has a vector direction where it is looking. You take that vector and you take the vector of the normal of the triangle and you do a dot product between them. And if it's, I think, negative, right, you have to don't render that triangle. I think that's basically the idea. Right, so because essentially the dot product tells you, sort of kind of tells you an angle between two vectors, right? Positive is positive is the same direction, right? And negative is just like, roughly, yeah. So it's not 100% that, but I mean, you can basically treat it in this situation as such. Right, so to do backface culling, we need to actually have normals of the triangles. As far as I know, in our pipeline, we do not extract the normals of the triangles. So the way we actually do this entire thing, right, we have OBJ file and stuff like that, and we are converting OBJ file into C code. And we're baking the C code into the C executable into the C program. In our case, when it's in browser, we're baking it into the WASM module, right? But it works actually outside of the browser. So did I already close? Yeah, I already closed it. Right, so this entire thing is obviously compiled with WebAssembly into WebAssembly, right? But then you have native versions of the same demos and they work outside of the browser. So in all of the cases, the model is converted into C code and baked straight into the program. So in case of the WebAssembly, it actually creates a very convenient situation that you don't even have to fetch any assets from your C program, right? Because what you can do, like, you just grab them from within the WASM module. You just need to load the WASM module and that's it, right? This is actually super convenient. So, and if you want to take a look at the native version, I think it's somewhere here. So it's going to be Panger 3D SDL. Right, there we go. So here is the native version in here. Right. So it's using SDL2 specifically. Works fine outside of the browser. See, you don't need browser, guys. You don't need browser. You can actually take and implement it like a very, very small subset of the browser. The only subset that your application actually needs, and you can ship that small subset of the browser with your program. Right. It's like almost like an Electron apps. Right. So in case of Electron, you ship in the entirety of the browser with your application, but the idea is, if you know a little bit of a proper programming languages like C and C++, you can implement a small subset of the browser, for example, like Canvas, and even small subset of the Canvas HTML. Right, so implement only the functionality of the browser that you need, implement your application on top of that functionality of the browser, and just ship them together. And overall, the application is going to be way smaller, way more responsive. So that's the new hot trick in web development. Right, so partial browser implementation, because obviously implementing the entire browser is kind of difficult, right? So you partially implement the browser. So partial implementation is actually way easier than the entirety of the browser. You know what I'm talking about? That's how you trick web devs into proper software development, by the way, right? So just by telling them bullshit like this. So anyways. What do we need? So we're converting that to C code. But as far as I know, we do not extract normals, right? So we do not extract normals from the OBJ. So this is probably something that we'll have to do. So let me go into the tools, OBJ2C, and in here I think what we're doing, we are literally skipping normals, right? So the normals are the objects or the commands of OBJ file which start with VN, if I'm not mistaken, right? So yeah, it is. Like, this code assumes that we already, so this is whatever. So this is a normal, and we are, it's actually, so yeah, we parsed, This one is interesting. I think we'll literally just ignore the n, don't we? Yeah, okay. So we count normals though, right? We count them, but we ignore them. So I suppose we count them specifically to report them in the building, right? So if I just do no build assets, right? So no build assets, at the end we are reporting how many normals and texture coordinates we have, right? But we don't collect them at all. This is just like additional information that we have in here. So I suppose we need to start collecting them, honestly, right? So we have to start collecting them in the same way we're collecting faces and vertices, right? Faces and vertices. So this is actually super easy because, again, the n is just the 3 floating points. It's basically a vector. Right, so it is basically a vector. So this is going to be, you know, a list of vectors. So here, vertices, if we take a look at the definition of the vertices, it's a dynamic array of a vertex, and a vertex is a little bit more complicated than what we may think. It has a position, and it also has faces, indices. This is needed for component analysis, right? So this is an additional thing. It doesn't really matter that much for us. All right, so let's introduce, I think, normals, right? So we're going to have normals, normies, and normals is going to be basically a sequence of the 3-dimensional vectors, right? So it's going to be vector 3. Do we have a vector 3? Yeah, we do. So this is a vector 3. Okay, so that's pretty cool. So this is the items, and here we're going to just introduce capacity, and we're going to just introduce the count. There we go, we have normals. So then in a place where we create, for example, faces, right, we create vertices, faces, we need to also create normals, right? So these are the normals. And we probably want to get rid of the normals count, right? So because the amount of normals is going to be the count that we're going to use, right? So I might as well even just try to rebuild the entire thing. Let's rebuild the tools. I think I have to go somewhere here, so let's rebuild the tools. And here, obviously, it doesn't compile, so here we just add the normals. So we need to try to parse 3 floats, right? We need to try to parse 3 floats. How are we going to be doing all of that? This is a good question. So we already parsed 3 floats with v. The easiest thing to do in here would be to literally copy-paste the entirety of this code into the vertex normals. Yes, it is okay to copy-paste. It is okay to copy-paste. Don't listen to your university professor. They don't know shit about software development. Copy-pasting is how you identify patterns within the code. And the more you can identify patterns, the more you can then compress them if it is needed. Without copy-pasting, it is almost impossible to identify patterns which you can then factor out into the abstraction. Copy-pasting is not only good, it is a very important tool of creating architecture from the bottom to the top. So, anybody who does any serious software development knows that. Right, that's how serious software is actually developed. Cheers for that. So that's pretty cool. That's pretty cool. So people have been subscribing and throwing money at me. Do people subscribe and throw money at your professor? I don't think so. So thank you so much, everyone who gifted me money. So Giuseppe 5000. I hope I'm pronouncing that correctly. Thank you so much for Twitch Prime with the message. Yo. So emote Penger, I do agree with this message, right? So I do agree with the message of Penger. Krusty, thank you so much for tier 1, and NGDLMK, thank you so much for Twitch Prime. Really appreciate that. Very poggers, my friend. So in here, essentially, the thing that is responsible for parsing the vector, right, is these 3 lines. This is for computing the range of the vertices, right? So the minimum x and the maximum x, the minimum y and the maximum y. We don't really need that in normals at all, honestly. This is kind of a useless information in normals. In vertices, in specific points of the mesh, we kind of do want to know what's the minimum x, what's the maximum x, what's the minimum y, what's the maximum y. So basically we know the box, the bounding box of the mesh. This is important. But in case of the normals, normals are basically the vectors that stick out of the triangles. They stick out of the triangles, and computing their ranges is just, it's a useful information. It doesn't give us anything. So I don't think we need this kind of thing. Right, I don't think we need this kind of thing. Right, and this is how we parse essentially. This is how we essentially parse the vector, right? So, and after that, we can create a 3D vector out of that. So it's going to be make vector 3, x, y, z, and then we're going to append that into the normals, like so. And this is how we support the normals. Let's actually try to recompile the entire tools. Right, so what do we have in here? So end PTR, we never actually defined end PTR. I think it has to be character, like so. Right, so it basically tells, so str to f just parses float, but then it tells you at which point it stopped parsing. So, and it does that through this variable end PTR, and because of that, it's very important to have this variable so we know where to cut out the stuff that we already parsed. So for more information, I really recommend to actually do man str to f, right? So I don't know how many people know that, but there is a lot of man pages for standard C library functions. They're super convenient, but you usually, depending on the Linux distro, you have to actually install them, right? So development pages and stuff like that. Right, so, and if you want to know more information about str2f, you can just consult man page, and there's a lot of information on how all of that scheisse works in here, right? All of that scheisse works. Right, and let's try to rebuild this entire thing. So we have to be in a different folder, so that's fine. And normals count. So this one is super easy, right? So this is just count, right? Because as soon as you just push them, they're automatically, this count is automatically increased. Okay, we do in fact collect normals. We do in fact collect normals. We can even kind of try to confirm that by, you know, running all of that shit through the debugger wagga. So let's do assets, right? So we are compiling the assets. The way we run obj2c on the Panger, it's this, right? So here is the command line that is used to convert Panger into C code. And the stuff that we probably want to do, right? So I want to copy paste this entire thing to a different place, right? So I'm going to grab the executable obj2c and I'm going to use gf2 on this entire thing. Right. Oh shit! I don't have gf2 on this machine because it's the latest machine. Fuck. Right. So growing pains of the new computer, right? Because you don't know what you're missing and stuff like that. Do I have at least GDB? Okay, so I do have GDB. All right, this is a good opportunity to actually take a look at GF. One would no GF, like, okay. So let's focus on coding, okay? Let's focus on coding. Let's go into next GF2. I think that's their nickname. What was the, okay, wait. Did I spell nickname incorrectly? I think next GF2. Please don't tell me I spelled... Oh, it's just GF. Okay, for those who doesn't know, GF is a front end for GDB that tries to make GDB look like a proper debugger, right? So that's basically what it does. And it's actually, there were a lot of wrappers around GDB, but I think this one is the best out of them, at least the ones that I tried, right? At least to my taste. Right, at least to my taste. I really like this one. It's a little bit janky, but this is because it's a wrapper over GDB. So GDB is built in a way that fundamentally you cannot create a robust and stable wrapper around it. Right, you just can't fucking do that, right? So any wrapper around GDB is going to be slightly janky. Right, so because the way it works, it injects a bunch of Python scripts into GDB. Like, I don't think there's any other way to do that, except maybe forking GDB and just modifying the source code and just baking something into that, but that's too hardcore. And you're gonna have a hard time maintaining that and actually backporting changes from the upstream of GDB. So it's a little bit janky, but it does the job relatively well. Right, so I'm gonna put that in the chat and in the description as well for anyone who's interested. It's really fucking cool. I really recommend to check it out and see for yourself if it's suitable for you. So, and it's relatively easy to build, I think. I think it is in fact relatively easy to build. So let's actually go to here. Right, I'm not gonna do third party. Do we have a third party folder? So third party, Nakarabati, and we are going to simply git clone this entire thing. All right. So this is what we've got, and there's a bunch of build scripts, right, for different operating systems: FreeBSD, macOS, NetBSD, OpenBSD. And after that, people say that Linux has way too many incompatible distributions. What the fuck is that? But I mean, those are like straight up different kernels even, right? So they're not like just distributions, they're straight up different kernels. They're basically different operating systems. Open-based, maybe that's what it is. Okay, let's try to build it and see if it works or not. Warning, free type could not be found. The fallback font will be used. Free type, I wonder who said that. Free type. So what exactly do you want? You want free type. Maybe we should actually install free type. So let me actually bring the root shell super quick, super quick. All right, and let's do xbps install. Maybe I'm gonna actually I don't have auto completion here. Query. I can actually do that in a different thing. So as far as I know, query doesn't require a root, right? So rs free type 2. Is it just free type? Oh, okay. So I just don't have the devil one, right? So I don't have a development one. Okay, so that's understandable. So let's just go ahead and install, right, this kind of thing. So honestly, I personally don't like to compare Linux distros too much because Linux is Linux, right? So as already said on Twitter, the reason why you distro hop is not because like some distros are better or worse than others. This is because Linux just fundamentally sucks and you're trying to solve a different problem, right? So you're trying to solve like a wrong problem at all. Linux just fundamentally sucks. You're gonna have bullshit on Linux every fucking time. It's just with different distros you're gonna have different bullshit. That's just truth, right? So it doesn't fucking matter. So if some like Linux fan tells you, oh, I never have any problems with Linux, they're fucking lying. They're fucking lying. On different distros, you just have different bullshit. You're gonna have bullshit all the time. This is an operating system for stinky nerds. That's what it is, right? So, having said that, what I like about Void is that its package manager is way faster than apt on Debian. It's like way fucking faster. But then I was told that it's not really an achievement of package manager Void. It's kind of a fault of Debian, honestly. Right. So apparently, for a package manager being this fast is nothing really special. It's just like apt sucks ass, right? So is that true? Because I don't really distro hop these days anymore too much. So right. So this is a fault of Debian, I suppose. apt is trash. Okay. So I basically was using apt for a long time. I kind of got used to it. So in my head, this is how package managers work. Right, so this is how package manager works. I think this is basically an effect that web devs experience, right? So they're constantly floating in a shared software, right? And that's why they think that 100 milliseconds response is very fast for an application. Right, so because they never see anything better than that, right? They're literally swimming in a shit, and because of that they think everything is shit and this is fine. So I think I fall into the same sort of trap, right? I think I fall into the same trap. Anyways. So yeah, we have a free type. I think I want to rebuild this entire Scheißung. Because I want to have a proper, fonts and shit. Fonts and shits. All right, so, and that's it. So we got GF2. So that's how fucking easy it is. So we can even try to run it, and hopefully it's going to run without any problem. Yeah, there we go. So it's a GUI application, by the way. A GUI application on Linux. So that's how quickly it was. And this is not because I have a latest laptop. It builds this fast even on my old laptop that is sitting here, by the way. It's sitting right here. So yeah, so it's pretty cool. And maybe one of the things I want to do, I want to actually copy paste this entire thing into maybe my user local, right? So on Linux, there is a folder called user local, right, bin, but specifically user local, right? And it contains sort of like a subtree, like a /user subtree in here. And this is a specific folder where you're supposed to put things out of package manager, right? If you have some software that doesn't exist in your package manager, in your repos, but you still want to have it installed on your machine, this is a folder where people usually do that. There is several folders like that. There is also /opt, but I think /opt is specifically reserved for proprietary software. Is it not? I think it's specifically for proprietary software. User local is basically where you would install a thing that you build yourself from scratch. There's also .local. Yeah, that's true. There's also .local. It's for one single user, but I kind of want to install this thing for all of the users because I have several users on this machine. One user for the main, right? So main account, and one for the streamer, right? I just keep the accounts separate. Because some settings are more convenient for streaming accounts, so some settings are convenient when I'm not streaming, right? So because of that, I keep them separate, and also for security reasons. So let's actually go ahead and copy paste that straight into user local, right? So I think I'm gonna just grab this entire thing, and I'm gonna just copy paste it in here. So, but honestly, I should have just done copy v / copy paste it in here, and then user local bin, boom. So yeah, I think I did a fucky wacky because it's 2. So it's kind of annoying, right? So that it doesn't contain 2 in the name of the repo, but then executable contains 2 is like, it confuses me every single time. Am I okay, I am an idiot, I'm sorry. Just one more time. Next, why didn't you just call it? Well, I mean, this time it's actually my fault, honestly. This is actually my fault. So it's gf2 executable, copy pasting it in user bin. Hopefully this time. It's a home streamer, right? Because it's. I know how to use computer chat. I'm also streaming, okay? I'm also shut up. Shut the fuck up, everyone. I'm gonna ban everyone. I know how to use computers. I swear. I'm just baiting donations. As a streamer, I'm just baiting. Okay. Finally, you see. I know how to use computers. I told you. I fucking told you. I was just baiting you. Haha. Anyways, so let's actually continue. Right, so where we are in Olive C. Olivettes. So we need to grab this executable, right? So I'm going to do gf2. I'm going to put it in here. I'm going to just run it like that. Use a new buffer. There you go. So one of the things we probably want to do, we want to actually maybe obj2c. I want to put breakpoints somewhere here. So unfortunately, there is a way to just navigate around and stuff like that, but I'm going to use a gdb command, right? So it's going to be obj2c at 494, and I'm breaking in here, and I'm running this entire thing. Actually, yeah, that was a bad idea, right? Because you have to run it with specific command line arguments, right? Which are located in here. So here is the gf. And I'm going to copy paste this entire stuff in here. There we go. And as you can see, this is a proper debugger. Doesn't it look like a proper debugger wagga? Look at that. Like it's like Visual Studio is in shambles. I mean, Microsoft Visual Studio C++ thingy, right? It's not the shady Electron one, but the original OG Visual Studio. This motherfucker is in shambles, right? Look at this. And this is just a wrapper around GDB. And it looks like a proper debugger. I'm pretty sure the product managers of Microsoft are having a meeting right now, an emergency meeting, discussing how they're gonna compete with this shit. They can't compete with that. Look how responsive it is. Look how fucking responsive. Look at that. The average web dev mind cannot comprehend how can you resize the elements this fucking response. How is this even possible? How the fuck do you even recalculate the layout so fucking quickly? Like, an average webmind cannot fucking comprehend how the fuck you can do that. Like, it's impossible. Like, what the fuck is this shit? Is that a dedicated hardware to do that? Holy fucking shit. Well, I mean, honestly, I'm on a new laptop, right? So you can say that's on a new laptop, but on an old laptop, it was as fast as this, right? So, but anyway. Can your Discord do that? I don't fucking think so. I don't fucking think so. Let's take a look at the normals. Did we manage to actually parse normals? Here they are. We actually managed to parse 594 normals, right? So this is actually pretty cool. We can take a look at what kind of normals do we have in here, and here they are. So it doesn't really display all of them, right? So it just thinks that it's a pointer to a single item, right? So one of the things we can do in here, I think, we can do just normals items, and then we can dereference it, and then we can say displayed as an array of size normals count. And there you go. So we get an array of these things. So this is basically not really a feature of GF2, but it's more of a feature of GDB, right? It uses the GDB syntax, right? Because it's on top of the GDB. And here are all of the normals that we managed to parse. Here they are in the memory, right? Here they are in the memory. So that's pretty convenient. So we just confirmed that we parsed normals correctly. This is actually super cool. But anyways, so the thing we need to do, we need to now bring them to the C source code, right? So we need to bring them to the C source code. If you take a look at how we generated panger.c, right? So this is the C code generated from that OBJ file, right? So here are the vertices, here they are. I pressed Ctrl-Alt-F and it's bound to create Thoner, which is the file manager of XFCE. Okay, who in XFCE, who among developers of XFCE by default mapped Ctrl-Alt-F to opening this shit? Who freaking did that? Okay, so let's actually try to remap it. So I think it's somewhere in the keyboard. Right, so I think it is somewhere in the keyboard. So here's the application. So where is the Thoner? And there's even two of them. Look at that. They're, okay, by default it's super E, but that was not enough for those motherfuckers. They needed to create another Thoner, which is called... I swear to God, people, like, why the fuck did you do that? I'm gonna go into the XFCE history and I'm gonna look at the commits and I'm gonna do git blame and I'm gonna find the person who did that. I'm actually joking. I'm joking. This is a joke. Right, so let's actually remove that. So, yeah, and basically Ctrl-Alt-F allows me to jump to the corresponding closing curly brace, right? So it allows me to skip this entire thing like this, right? So this is very convenient. And Ctrl-Alt-B allows you to jump back. Can your Vim do that? Well, it can. It's actually %. I know how to do that in Vim. Right. So you stand on the parent, right, and it's just press %, and this is how you do it. So here's the faces, right, and we only have vertices and faces, right? We only have vertices and faces, and so what we need to do, we just need to add normals, essentially. We just need to add normals. The way we generate this entire thing is actually with just printf, believe it or not. We just printf this motherfucker and it just works. So I have too much hair in my face. All right, so let's actually see. I think, yeah, here is the function called generate a code, I mean. Right, so it accepts the file into which we're generating shit, vertices, faces, and yeah, so we have a functionality that allows you to delete some compounds, right? So basically fully connected compounds of the mesh. We used it to analyze the mesh, but I don't think we really need it anymore. But this functionality stays in here just in case, because it's kind of a cool functionality, just hoarding the code, right? And as you can see in here, we're just like generating the stuff, right? So I suppose one of the things we want to do in here, we want to introduce normals, right? So here are normals. Okay. Cool. So now, after we generated the faces, maybe actually before we generated the faces, we want to introduce normals, right? So let's actually go ahead and copy paste this entire thing, right? So this is going to be normals, normies count, right? So normals, here they are. So after that, we probably want to generate this kind of thing, right? So this is vertices and this is normals. 3 of them, and we're just closing this entire stuff. So, and what we need to do, we just need to iterate this entire thing. So it's going to be 0 normals count plus plus I, right? So I'm going to put it in here, and then, so the way we do that, I think we can just generate this entire stuff as we do with the vertices, but here we can just do normals. I think it's VN, right? It's going to be VN. I might as well quickly do VN. And this is normals. There we go. So that's it. So that's how we add generating of normals in here. That's how we do that. Super easy, super peasy, I would even say. So let's try to now do no build tools. This is not what I wanted. I didn't want a slash, and it doesn't compile because is it position? It's just that, right. So the normal itself, the item itself of the normal is vector, so we don't have to do like, you know, one layer of indirection. We don't have to do that. Scheisse. Generate code, and in here we just have to pass normals. All right, that's cool. That is fucking cool, and it compiled. So let's generate assets. Let's take a look at the assets. Everything generated successfully. It was super fast. Look how quickly it does all of that under 100 milliseconds. Under 100 milliseconds. So for a web dev, if the server responds with 100 milliseconds, that's already super fast. We generated shit ton of different assets with like 50 milliseconds. 50 milliseconds. Fucking 50 milliseconds. Below 50 milliseconds. That's what happens when you use a real programming language, not a fake toy one. Just saying. Just saying. Let's continue. So yeah, let's take a look at the shit we generated in here. Let's take a look at the shit. So this is the panger, right? So here are the vertices and here are the normals. Look at that. So here are the normals. Here are the normies. So that is very cool. But I think one of the problems we have in here is that we don't really know association of the normals in here. This one is rather interesting. This one is rather interesting. So because as of right now in the generated code, we provide only the vertex. Like, so this is the index within the vertex array, which tells what vertex of that face we're using in here of that specific face. So these are indices within the vertex array. So, but normals for all of these faces, right? So for all of these faces, normals are also kind of done like this, right? They're indices. They're straight up indices within faces. So how we accommodate them? So one way to accommodate them is probably maybe finally create a structure, which is face, right? And then just put that stuff in here. Or maybe we can try to extend the face, and I'm gonna say that we're gonna have 6 things in here, right? And just add the normals in here, right? So here we're gonna have normals. And I kind of prefer this solution. You know why? Because there is a code that already uses this API. Right, it already uses this API and it uses this thing as an array. So if I just add normals as 3 additional things in here, that shouldn't break any of the existing code. Right, that's a very easy backward compatible way to extend the definition of the faces in the generated code. You know what I mean? I think this is a good idea. I think I just should extend it to 6 now and then just add normals in there. Yeah. I think that's pretty good. But it depends, like, what's the order, right? So because in the OBJ files, if I take a look at the faces, right? So here's the panger OBJ. So there is a face in here. Here it is. And here is the triple. I know for a fact that the first thing is a vertex, but what's the next thing? Is that a texture or is it a normal? I do not quite remember, so we need to actually consult with the source code when we're parsing the face. Okay, so the second thing after the vertices, according to the OBJ format, it's the texture, coordinates, and only then the normals. Right, and because of that, in the generated code, I would prefer the next triple be the texture coordinates and only then the normals. I think that would only make sense. So we're going to define them in the same order as they are defined in the OBJ file. I think that's fair, right? So because otherwise you're going to create a confusion, right? So right, it's the same in the format and it's the same in the code, the same order of the things. So because of that, I think we need to learn how to parse the texture coordinates, right? So here we learned how to parse the normals, and then we need to learn how to parse texture coordinates. But it's actually the same, right? So VT, right? So VT, it's actually slightly different. Texture coordinates is a two-dimensional vector, not one-dimensional one, right? So, but I mean, that's fine. So we can easily do that. So let's go to the OBJ, Baba G. It's OBJ, not G, but G. Okay, so I don't know the difference between G and J. I don't speak English, I'm sorry. Baba G. So we need to introduce, do we have a vector 2 actually? So yeah, we do have vector 2. Okay, that's perfect. We have a vector 2, so this is the vertices, and we need to introduce texture coordinates, right? How should we call that? So this is going to be textures. I don't know. So let's call it textures. So it's more like a texture coordinates, but I don't want to call it texture coordinates. So text chord usually, okay, so text chords, right, so we need to emphasize that it's plural. It's very important because there's several of them, because this is the dynamic array. Size T capacity, and this is the count, right, so we have text chords. Yo. I think I need to acknowledge the subs. Thank you so much, everyone. Glitched out. Thank you so much for tier 1. Forcing E indeed. Juan CB, thank you so much for Twitch Prime. My learner, thank you so much for Prime with the message. You definitely need support. Thank you. Thank you. Nutrix Dev, thank you so much for tier 1 subscription with the message. You got me. Okay, so I'm really proud of myself. Anshai, thank you so much for tier 1 with the message. Cool angle, rest in peace i3 though. Maybe we'll get to i3 at some point, alright, so maybe we'll get it, because I kind of like it, but I want to try to find the best of both worlds of XFCE and i3, right, so I want to have a convenience of this integrated desktop environment, but also the convenience of a tiled window manager, right? So XFCE has some sort of like tiling capabilities, and maybe they're going to be sufficient for me. I don't know. So I need to play with them a little bit. Yeah. So there is a little bit of a tiling with XFCE. So I need to just see if it's sufficient enough for me. Because honestly, I wasn't using that much tiling in i3 either. Right, so usually the tiling that I use, I would just like slap all of the windows together into tabs and just switch between the windows and they're all full screen, or sometimes I would just split it into left and right. Very rarely I would need to create a very complex layouts and stuff like that. It's like actually very rare occasion. So I suspect that the tiling window capabilities of XFCE would be enough for me actually. I think that would be enough for me. Right. So let's actually go ahead and create texture coordinates. Right. So let's do text chords. Text chords. And there's several of them. So I even called them texture coordinates. I decided to use the lame name, right? Because naming things is hard. Right, so it's kind of interesting how now we have like basically the representation of the OBJ format, but in the code, right? So we have vertices, faces, normals, text coordinates. Maybe it makes sense to actually put them like this, right? First come the vertices, then the texture coordinates, the normals, and then we define faces, right, in terms of all of these things, right? Faces just contain indices within these arrays, right? That's what it is. So let's find VT, and basically it's the same thing as anything else except it's a two-dimensional vector, right? It's simply a two-dimensional vector, right? And we're just appending the two-dimensional vector into the text coords, right? So this is text coords, and in here this is just 2, and this is just that. So let's go to the compilation errors. So let's compile the tools. So text coords count. All right, everything compiles, and let's actually generate assets. Looks cool. And in the generate code, let's also start generating texture coordinates. We can even copy paste this kind of stuff. I might as well even do a little bit of query replace. Normals, text coords. Boom, 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 boom. There we go. Who needs templates if you can just copy paste code and query replace shit? You don't need templates. Code reuse is just copy paste. A truly reusable code is the one that you can copy paste. Software wisdom, software development wisdom. Because when you copy paste the code, that's the literal act of reusing it. It's by definition reusable because you are in the middle of fucking reusing it. It's not obvious. It's not fucking obvious. People should be fucking obvious. Anyways. Right, so let's try to recompile this entire thing and see, well, I mean, yeah, so we need to also pass the texture coordinates. Let's pass the texture coordinates. I would like to maybe move the faces somewhere here. I like to preserve the same order as in the OBG format, in the BabaG format. Text coords, BabaG format. Right, let's go to the compilation errors, more compilation errors. VN, because it's a VT. Yeah, okay, so that has to be something like this. Right, I forgot that it's a two-dimensional vector, not three-dimensional one. But luckily, compiler told me that, because I'm using a proper, statically typed compiled language, unlike some toy dynamic one. Yeah. And that's why I catch all of these errors, because I'm using proper programming language. Right? All right, and all of that compiles. They make browser in shambles, exactly. They're in fucking shambles. Defer. I have a defer at home. So that's such a silly concept I came up with, right? So defer is basically like the code that is executed at the end of the function, and there is a return defer, which effectively, just go to defer, but also assigning the result variable. So then at the end in here, you return the result. Yeah, it's kind of silly. It's not even a proper defer, honestly. It's not even a proper defer. Because proper defer actually does this kind of shit at the end of the scope. This thing works only at the end of the function body, right? It's not even like a scope-wise. But honestly, quite often you want to do defer on the body of the function rather than in a specific very small scope, right? So, and that is sufficient enough. That is enough for 80% of the cases, right? So, yeah. It is what it is, and it isn't what it isn't. Is it not? People say GitHub is down. Are you debating me? Are you debating me? I don't think GitHub is down. So let's actually see. No, it's not down. Mods. So, yeah, we've got this stuff. I think we should try to maybe rebuild this entire shit. So this is going to be, what is it? Tools, right? So we do tools, and then we do assets, right? So here are the assets. And let's maybe take a look at the assets. So what do we have in here? What do we have in here? So we have vertices. Okay, that's old news. We already had that. Here's the texture coordinates. Here they are. We successfully parsed the texture coordinates. Here they are. Here are the normals. Okay. And here are the faces. Pretty cool. So the next thing we need to do now is effectively just put all of the indices for the rest of the things. Do we collect them even in the faces? I do not quite remember. So what's the faces definition? So you have a single face. Aha! We do have all of the necessary information in the faces, bruvs. In the faces, bruvskis. So we just need to bring that info into the generated code. So let's just go ahead and do that. Right, so let's go into the generate code. Right, and where do we generate the faces? Okay, so here they are. So we need to make it so +2, which is the texture coordinates, and +3. So it's basically 8, isn't it? Right, 6, 7, 8. Yeah, so it's basically 8. So in here, we're going to have, why is that D? Oh, because it's the indices, right? So this is that. Then this one is F VT, so it's a texture coordinate, and F VT1. Wait a freaking sec. Well, yeah. So it's indices. So that's why there are 3 of them, because they're per vertex of the triangle. So that's what they are. So this is 2. And since it's 3, it has to be 9 then. Okay, so I got confused, right? So I'm confusing myself right now. And then, so this is only textures. And then this is going to be the normals. The normies. So the yes. Okay, that's fucked up a little bit with my multiple courses shit, and it didn't even work properly because I fucked something up. Anyways, let's go ahead and try to rebuild the tools. We're rebuilding the tools, and let's rebuild the assets. Okay, so that's pretty cool. If I take a look at the banger, your mom's banger, and find the okay, so look at that. So we have 9 components in here. So the first 3 are the indices within the vertex array. The next 3 are the indices within the texture coordinates array, and the last one are the indices within the normal coordinates array. Right, for each individual vertex of the face, we're accommodating all of these things. Right, all of this data is available. The size of this file is actually 3020 lines. It's a pretty huge file, but this is because it is automatically generated. This is a generated code. Generated code. So we wrote the code that wrote another code. Wait, is that AI? Wait a freaking second. We are looking at the program that was created by another program. Human didn't write this code. Human didn't write this code. Human physically cannot write 600 lines of code. It is physically impossible to just mechanically do all of this shit. This was written by a program. This one. AI will replay. Holy fucking shit. This is a superhuman code. Human cannot write this code. Like this, look how unhuman this code is. This code is absolutely fucking unhuman. Right. So that's it. The programmers are done. Computer can do that better than any programmers. That's it. We're all gonna lose our jobs. Because like somebody can just write a program that writes all of that code for you. Like, holy fucking shit. It's fucking over. I'm telling you, it's fucking I'm sorry. It's a Jover. You know what I want to do, broskis? I want to rebuild the entirety of the shit and see if I didn't break anything, because I modified the basically the signature of the face array, so that may potentially broke things. But again, I intentionally did so things do not break. So hopefully everything's gonna be fine. So we'll see. All right, I'm gonna do the full rebuild, and so it probably will compile, right? It probably will compile. Okay. So there's some warnings. Let's take a look at the warnings. So these are the warnings from this thing. This doesn't matter. Sodium cup low poly. So essentially, I actually run compilation in several threads. So if a demo, right, so demo can be compiled to terminal output, to the SDL output, or to the WebAssembly. So, and basically all of the three platforms, I compile them simultaneously, right, in separate threads. You are observing literally the result of a race condition. It is so comically textbook, it's insane. It's comically textbook race condition. Like, how the fuck did that happen? This is so fucking fun. I love it. This is so funny. Right, and they failed with the same error, and the same error started to output at the same time, and they're starting to compete for the output. And that's why they're just like merged together like that. Holy shit, this is so fucking cool. Slow-mo compile. This is just fucking cool, isn't it? Right. If you don't find this cool, you don't like programming. You're just an imposter. Telling you. Calling you out right now. If you don't find this situation fucking cool, do you even code, bro? Or are you just here for the grift? Or are you just here to just fork VS Code and make a bunch of money and just dump it like everyone else? If you really don't find it fascinating, we will never be friends if you don't find this fascinating and cool. We will never be. I won't even consider you a programmer. You're just a grifter. Okay. Anyway, so I'm already streaming for more than 1 hour. And I think the time has come to make a small break and make a cup of tea. So yeah, the time has fucking come, mate. All right. So how are we going to be solving this race condition thingy? So what I'm thinking is that we can try to build a specific example where it fails. So it's a cup low poly. Right, so it's something about teapot. So let's go ahead and try to do that. So assets, right, we're rebuilding the assets. Well, I mean, it's actually demos, right? So there's a demos. So far the things worked fine, but something was with the teapot 3D. Right, teapot 3D. And then I want to actually build only SDL. Yeah, there we go. So with the SDL, it works more or less fine. Okay, so we have empty arrays. Understandable. So one of the things we can try to do, let's not generate these things if the arrays are empty. Right, that's one thing we can do. Right. So when we generate in the code, maybe it can be a true for all of them. So essentially, if they end up being, to be fair, like, I don't know, why don't you just allow an empty array, brother? Using of empty initializer. It's about empty initializer. Is a 23 extension. One of the things we can do is if vertices count is equal to 0, we essentially just print something like that. We say it's an empty array. Maybe even... Right, because having an empty array is kind of a useful case, right? It's like a useful special case, if you know what I mean. Right. And that would be kind of cool, and that would be kind of based. Kind of cool, kind of based. Kind of cool, kind of based. So what we need to do is just... So I'm putting 0 in here because I'm not sure if that is going to be allowed. So yeah, let's actually put it like this, right? So just see what's gonna happen, because then later it is easy to change that if it is needed, right? It is easy to change that if it is needed. So this is the texture coordinates. And I think, do we need to do that on all of them? Normals do need that, but maybe also the faces. And faces are very special because they're kind of like a visible faces, right? So because you can have some of the faces removed. Right, one of the phases removed. So let me see. So this one is gonna be normals, right? So let's put it this way. If normals equal to 0, what the fuck is that? So let's put it this way, and else. All right, so this is normals, and last thing is faces. Familiar faces all around me. Sorry, I don't know what to say. Okay, I'm just typing code. This is why nobody likes programming, by the way. This is why nobody likes programming and people watch reactions and shit like that, because actual programming, well, I mean, I wouldn't say it's boring. I'm having fun right now. I'm not joking, I'm having fun right now, but at the same time, like, how can I make it entertaining for somebody who's a third-party observer of what I'm doing? Right, so I'm just wrapping a bunch of stuff with if statements and stuff like that. Like, how can I make it entertaining? It is entertaining for me, don't get me wrong. I'm having so much fun right now. Hot tub programming, maybe this is what I should do. Maybe if I did all of that in a hot tub, right, so I could just do a very boring shit and just like market it as, I don't know. I don't know, like, I don't think I'm gonna be a good hot tub streamer, honestly. I don't think I have a talent for that. But anyway, so start typing with your feet. All right, thank you so much for the support, guys. I really appreciate you. Your beatbox, maybe I could actually beatbox when I'm doing something, you know, some boring stuff, right? In refactoring, I can start beatboxing while I'm doing that, so people are entertained, people are engaged, yo. Anyways, being streamer is hard. Oh. So visible faces, yeah, we probably want to remove that shit, my friend. Let's go. Let's fucking go. Let's do assets. We generated some assets. And let's try to maybe build a teapot. Right, so building that teapot. Okay, so tentative array definition assumed to have one. What the fuck is tentative array definition? I don't even know what the fuck the word tentative means. Why C compiler throws at me words I've never seen before? What the fuck is a tentative array definition? Let's Google it up. I don't fucking know. Do I even speak English? Do I even know programming? So, like, what is a word tentative? Like, Oxford Dictionary. Like, I don't know what it means, like, on the level of, like, language. Oxford Dictionary. Like, what does it mean? Oxford Learner English Dictionary. Give me the definition of this word, please. Right, so let's take a look. Tentative. So, of the nature of an experiment, trial, or attempt, made or done provisionally as an experiment, experimental. That's what it means. It's an experimental array definition. Tentative, temporarily decided for now. Okay, so that makes much more sense. Like Oxford Dictionary. Do you even speak English, Oxford Dictionary? Do you even speak English? So, where was the Oxford? Oxford. Where is it exactly? It's in England. It's in Brit. So it's Brits who actually made this dictionary. So no surprise they don't know how to speak English, anyways. So I'm joking. I'm so sorry. I'm fucking joking. Tentative array definition. See global unsized arrays. Right. Right. So it's incomplete type. I see. What we can do in this specific case, tentative array assume to have at least one element. Right, so if you end up with a thing that doesn't have anything, what do we do in that case? Do we just say it has one? Right. So, but we put 1 in here because we can't define an empty array in C. Right. So, but we're gonna keep the counter 0 because we don't have anything anyway. Right. Define has normals. This is a good idea, honestly. This is a good idea. So then, on a level of the compilation, you can actually decide whether you have that shit or not. But honestly, it's too much. It's better to have a natural sort of base case where the code that just iterates all of the faces works as intended. So if you have 0 face count, it just does nothing. Right? Has normals forces you to do additional thing of checking whether the normals were generated or not. It doesn't matter. They're always generated, and if there's no normals or vertices, they're just 0. It just makes everything simpler. Not that many, moving parts and stuff like that. So I think I don't want to go with that. Right? I think it's better to just put like 1 in there in all of these cases. Yeah. So we're gonna just put 1. So that's right, and that. I think that makes sense. Somebody suggested using the heap. Mods? You know what to do. I'm joking, don't do anything. It's like, it's kind of funny. Look, the whole point is to bake static data into the executable, and using heap for that is just like... But I mean, we can use heap, but that means we have to copy the data from somewhere into that heap. Where are we going to be copying it from? It's kind of like a... And we end up at the square 1 again, right? So we need some place where in obj5... Okay, so you're suggesting to decouple these things and basically having problems that we're trying... Okay, I see. Cheers, by the way. It's pretty good tea, actually. I really like tea. I really like this tea. Okay, so let's try to build this shit. So this is tools. Okay, that's pretty cool. So the tools compile. So assets. All right. Teapot. Let's take a look at the teapot. Compiles perfectly. Chat, it compiles perfectly. Right, we can try to compile the rest of the things. And they also compile perfectly. Right, so we can do a build demo teapot SDL. Works. This is the teapot. This is the teapot. So do I still have the local, server running in here? So is it still running, right? So, and this thing works. Everything seems to be working. So the thing I want to do now, I want to rebuild all of the things to make sure that nothing is broken. All right, so there's some warnings, but they don't matter. Okay, so that was literally the problem in here, right? So just to be compatible with all the C compilers, we just add one element to that array and everything is Gucci, everything is Tamaguchi. Pretty cool. So we have information about vertices and stuff like that. So let me actually quickly refresh the whole thing, right? And go through all of the demos and see if they still work, right? So Sojin a pogue, rotating pogue, right? And this is the panger, your mom's banger. So I suppose the thing that I want to try now is probably the backface culling. That's the thing I want to try. But what's funny is that, I'm not even sure how we're going to be doing that, because it's easier to call, the faces rather than the vertices. How are we going to be doing that? Right. So I want to call specific face. I look at the vertices of those face. Mods! Freaking... Stop trolling me with this shit. Okay, so... freaking GL call face. Like we're not even using OpenGL. Like we are rendering this on CPU pixel by pixel manually. It's just the person who said that probably knows that, right? So the person who said that, yeah. Gel call face, gel back. Yeah, exactly. Thank you. By the way, the fans are going nuts. I wonder what's up with that. 76, by the way. Even CPU is kind of low. I'm having my like cooling stand working. I have the fans of the laptop working, and it still goes to, well, it doesn't, it's not 100 at least, right? So it's not 100 at least, and it actually went down because it's not rotating anymore. Once it starts rotating, it actually takes a little bit more, right? So yeah, it's kind of interesting. But anyway, so how do you fucking do that, right? So I want to call a specific face, right? I want to call a specific face. How do I decide whether the face should be called? Right. I look at all of the vertices. If all of the vertices should be called, I call that face. I think that's a good solution for now, at least. Right, because I feel like, what if we have a situation when some vertices of the face should be called and some of them should not be called? How do we like approach that? So do we construct a new triangle that is like, or whether you're gonna have such situation at all? Right, that's a good question, actually. That's a good question. How do you even fucking do that? So what's the usual thing? You still need to render the face. So we render the entirety of the face then. Okay. All right, so let's give it a try. Let's go ahead and just give it a try. So let's take a look at the demo. Right, so there's a demos, and we're using the same thing for all of these 3D demos. If you take a look at the Cup 3D, we just include Model 3D. Right, so all of them are the same. All of them are the same. So this is essentially where we have to do all of that. So how we perform the render? So this is the VC render, which is the function that is called by the engine every once in a while, right? So 60 times per second. And this is where we do the rendering. So look at that. This is just a loop over the faces and it just renders it, right? This is the entirety of the rendering of the 3D model, honestly. Right, so let me actually zoom out. This is the entirety of it. Right, so it's just a loop over faces and there's 45 lines. Right, so there's a bunch of mass in here and so on and so forth. So which is pretty cool. So in here, as you can see, we take the vertices and we'll call them ABC because it's an old convention in here, right? We call them ABC. So what I would do these days, I would call them V1, Zul, V2, and V3. Right, so this is how I would call them today, but that will prompt a bunch of refactoring, which is, well, we'll have to, wait a second. Fuck. So V1, V2, V3. So because we're looking up those vertices, right, so we're looking up these vertices. Right, and this is how we construct all of them. So maybe because of that, I'm not gonna actually make them. So those are indices. Those are just indices, but we'll then have to do the normals. So let's go ahead and maybe do that. So ABC, let's call them N, A, and B, and C. And this one is gonna be more like 3, 4, 5, and 6, 7, 8. So I feel like we need to have a specific names for all of them. I think we need to have specific names. Something like, let's put enum face index, and here is just like a face V1, V2, V3, then the next one are the textures V1, VT1, VT2, V3, and the next one is N. So that way we can just do it like face V and1, right? Face V and 2, face V and 3, and in here face V, 1, 2, 3. Right, so here's the normal, right, so here's the normal. But this is the normal indices, right? These are the normal indices. One of the things we have to do in here is to construct those normals. It's kind of interesting. So here's the vertices, the coordinates of the vertices. We just update them and stuff like that. So I do a little bit of a like adjustment for Z in here. So I actually, yeah, I basically offset it a little bit forth. So that's actually kind of funny. It's actually kind of funny, right? So then it's visible in the camera because it's located at 0, 0 at the position of the camera. So it's kind of stupid. Right, so I have set it a little bit so it's in front of the camera, right? So I modify the model as I render it, and then I project each individual vertex in here. So this is kind of funny. I project 3D to 2D, and then I project 2D to screen, right? Because screen has slightly different coordinates. Yeah, screen has a Y going down and width going to the right, but when I project 3D to 2D, I actually assume the 0 to be at the center, right? So because of that, this is such a cool fucking code. The fact that like this code was written a long time ago and I still kind of can get like a grasp of it is so fucking cool. But honestly, I would like to maybe keep this thing somewhere here like that, right? So then I can do something like Vn in here. And then we have a vertices. In all fairness, can I just like reuse A in here? So because I originally have ABC, so and I just like reused it like this, and then ABC is a completely different thing in here. Because of that, it would be kind of better to maybe even do something like this. So I pre-allocate them, so it makes it easy to copy-paste code around. Yeah, so then I can do something like normals. What was the thing? How do you discard multiple cursors decisions on whether to repeat commands for each cursor or not? I forget. So it's MC list L. Yeah, run once. Fuck off. Okay, so let me try to do that one more time. What I want you to do is yes, normals. Boom. But this is not true. Oh, it is true, right? So because it's not a dynamic array, it's actually a baked array. So we have these three things. These are normals. And let's actually see if it's still compilable. So I'm really curious. Let's rebuild everything. Probably rebuilding everything is an overkill, but okay. So okay, it complains that the variables are unused. At least it doesn't do the race condition anymore. That race condition thing, it doesn't do that anymore. It's actually rare. I think the thing when all of the processes started to output at the same time the same thing, where the character started to interleave, it's actually kind of rare because it doesn't happen here anymore, even though it should. Alright, so it's kind of funny. It's a very rare occasion, like it's a golden legendary race condition. Alright, so here are the normals, and we need to figure out what's the camera angle, so to speak. So since the camera vector, since we're moving the model, the entirety of the model forward by increasing z, that means that the camera vector is 0, 0, 1. Right, it points towards z, positive. So we can say something like a vector 3 camera is 0, 0, 1. Right. And so now we can just do a dot product between camera, vn1, vn2, vn3. And if all of them are negative, we can try to call it. Am I right, broskis? Am I right, professional graphics programmers? So when they're positive, they're looking, they have to be actually, yeah, so when they're positive, they're looking in the same direction, right? They're looking in the same direction. And in that case, we want to call that thing, right? Sort of, you normally have a single normal per face, You have 3 normals per vertices. Yeah. So I think the thing we're gonna do in here, we're just gonna do dot product between each vertex, and if all of them positive, then call the entire face. If some of them are not, let's just run the face just in case, right? So negative means the triangle is facing away. I think we should just try both, right? So I think we just should try both. Right, so how are we gonna even fucking do that? So we need to check all 3 of them. If all 3 of them is that, then we need to do that. Okay, do we have any dot shit? Dot, no we don't. Vector 3. I suppose we need to create a dot product. So let's go ahead and do that. So we're going to float dot, maybe vector 3 dot, and vector 3a, vector 3b, because I don't remember having it anywhere. I don't really include any special functions or anything like that. I do have vc.c. And do I have a definition of vector? No, I don't. The definition of vector 3 is actually located in here. So VC does not even do any 3D, right? So it's literally up to the demo to do all of the 3D projection and stuff like that. Okay. So let's go, I suppose. Let's go. So we're going to return AX, BX plus, and let's actually put this kind of stuff in here. So we're going to do Y, Y, and this is going to be Z, Z. All right, so this is the dot. And so vector 3 dot camera VN. So we want to do that 3 times. All right, and let's say if it's greater than 0 in all these cases, right? And maybe even something like that, right? If all of these things at once, then continue. I wonder if that will work. I wonder if that will work. So let's go ahead and just rebuild the whole thing. Honestly, ooh, you know what? This automatically applies when you have normals. No call comment, literally unreadable, yeah. So it probably will fuck up something with the current demos. I think it will. I think it will fuck up something with the current demos. No, it didn't fuck up any. Oh my god, it kind of worked. But it's absolutely fucking wrong. Like, what the fuck is that? What is it? Why is it like that? The motherfucker is glitching all over the place, holy shit. But you can kind of see that behind the outer shell there is something. So that's the shell has weird word. They're actually inwards. They're actually inwards. That's kind of the point. I have a strange feeling that maybe I do not update the indices properly. I think I just don't update the indices properly. Let me take a look at the OBG to see. Right. So when I parse the face, right? When I parse the face, so I just parse the face triple, and this is just an index, right? So this is a face triple, and within that index, all right, so this is just VT. Do I do -1 anyway? Yeah, -1 is to account for one based in. Okay, so that's good. But we have to do that. We don't do that neither for the, yeah, we have to do that for texture coordinates and for the normals, right? So I literally forgot to do that. I kind of anticipated that I'm going to have such problems, so yeah. This is very important to do it like that. So this is very important. And because of that, yeah, we'll see, we'll see. All right, so everything recompiled. And if I try to take a look at this thing, so I think now it will fuck up something with the models. No, it didn't fuck up that stuff, it didn't fuck up that stuff. Yo, it works. It works exactly as it's supposed to work. So this thing is supposed to create the outer shell. So if you color that outer shell with black, it will create a black outline. That's kind of the point. So we have a backface culling already. That's actually super cool. Yo, what the fuck? This is so fucking cool. The question is why backface culling works here. It looks trippy. Yeah, it looks kind of trippy. So this is the thing that I kind of showed at the beginning of the stream. We can try to like show that one more time. So let's actually go to the Blender. Super quick, right? So, and I'm going to just remove this thing, and I'm gonna import. So this is the programming. Can I sort by modified? So it's actually not Olive C. Assets, Panger, OBG, Babaji. So this is called backface culling. So essentially, you can see this black outline, right? So how do I rotate it properly? Yeah, black outline. So this is the outer shell with inwards normals, and they're basically culled. Similarly to how we do that. They do that much better, right? So, because they probably do that on the level of vertices and stuff like that. We don't really have a mechanism to do that easily, unfortunately. And that's why the outline in our case is going to look a little bit weird. All right, it's going to look just a tiny bit weird. Yeah. So you can see like individual triangles popping in and out of the existence. But in reality, what they should do, I think they should just remove, maybe create a new triangles, right? So I don't know. Normal interpolation, so some sort of a normal interpolation, but this is something that I'll have to learn, right? So I didn't really know how to do normal interpolation and everything. Ooh, oh my god, I think I know how to do that. Dude, we're using berries. So essentially, this culling should be not on the level of faces, but on the level of fragments or pixels, right? So you have to build something similar to Z-buffer, right? And then you interpolate normals. Yeah, on the level. Oh my god. Oh, I understand. I know how to do that. I fucking know how to do that. I just didn't expect. Well, I'm not sure if we'll be able to do that on today's stream, right? So, yeah. Okay, that's a very interesting thing. So this is something that we definitely should do. And I'm already streaming for the entirety of an hour, for 2 hours. So this is the entirety of the stream. I guess the topic for today's stream was basically backface culling, and the actual, texturing and stuff like that we're gonna do on another episode. So, yeah. All right, so I guess I learned something, right? I learned something. So we're getting closer and closer to properly rendering this motherfucker, right? We're getting closer and closer to properly rendering it. So, which is kind of cool, right? So backface culling, right? So that's something that I would commit today. So let's go ahead and actually do that. Pretty good topic for today's session, honestly. I think it's a good place to finish the stream, right? So implement backface culling for 3D model demos, right? And I'm going to push that right into the repo. So I guess that's it for today. thanks everyone who's watching right now. I really appreciate that. I hope you enjoyed the new camera angle, right? So I think it's pretty good, right? It's better than whatever we had before, right? So if I take a look at myself at full screen, yeah, it's good. It's pretty good angle. It's pretty good. So thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recursion backend session with Ahu Amistazun. And love you all. Mwah.